200-amp main breaker on a capacitor bank connected to a coilless AJAX furnace trips when the furnace starts. Here are some potential reasons for the excessive current draw. Firstly, consider the cold start. When the furnace is started from a cold state, the capacitors require an initial charge resulting in a high surge current. This surge can be significantly greater than the normal operating current of the furnace. Secondly, examine the capacitor bank for any malfunctions. A failing or aging capacitor can cause an increased current draw, which could trip the breaker. Each capacitor should be individually tested using a capacitance tester or an ohmmeter to find any faulty units. Thirdly, investigate the possibility of arc formation. Arcing between the capacitor terminals or within the furnace chamber can create a high current fault. Carefully inspect the furnace chamber and capacitor terminals for any signs of arcing or burn marks. Fourthly, verify the impedance matching. The capacitors and the inductor, which is the furnace coil, must be properly matched to achieve optimal performance. If the impedance matching is incorrect, high currents can result, potentially damaging the equipment. Ensure that the capacitors are rated for the correct voltage and frequency specified for the furnace. Fifthly, check for loose connections. Poor connections in the electrical system, particularly at the capacitor terminals, can create resistance and lead to a high current draw. Inspect all connections and tighten any loose wires. Sixthly, consider overheating. Excessive heat can degrade the capacitors and increase their resistance. This degradation can lead to a higher current draw. Verify that there is adequate ventilation and cooling around the furnace and capacitor bank. Seventhly, check for power system instability. Fluctuations in the power supply voltage or frequency can create issues with capacitor charging and operation. Confirm that the power system is stable and within the parameters specified for the furnace. Here are some troubleshooting steps to take. 1. Visually inspect the capacitor bank, furnace chamber, and electrical connections for any visible signs of damage or malfunction. 2. Test each capacitor individually to identify any faulty units. 3. Verify the impedance matching between the capacitors and the inductor. 4. Inspect the power supply system for any voltage or frequency fluctuations. 5. Check for any loose or overheated connections. Finally, consult the manufacturer's manuals or a qualified electrician for further troubleshooting and repairs. When evaluating capacitors with a capacitance meter, compare the readings to the nameplate values listed on each capacitor. Significant deviations indicate a potential issue. For example, if a capacitor is rated at 100 microfarads and the meter reads only 50 microfarads, that capacitor may be failing. Similarly, when checking with an ohmmeter, a healthy capacitor should initially show a low resistance that gradually increases as the capacitor charges. A capacitor that shows either a very low resistance continuously or an open circuit is likely defective. Regarding impedance matching, the total capacitive reactance should be close to the inductive reactance of the furnace coil at the operating frequency. The formula for capacitive reactance is Xc equals 1 divided by 2 pi frequency times capacitance. The formula for inductive reactance is Xl equals 2 pi frequency times inductance. An imbalance between Xc and Xl can cause excessive current flow. Confirm that the power system voltage remains within acceptable limits as specified by the furnace manufacturer, typically within plus or minus 10%. Use a power quality analyzer to monitor voltage fluctuations and harmonic distortion. Excessive harmonic distortion can also contribute to increased current draw. When checking for loose connections, pay close attention to the connections at the capacitor terminals, busbars, and any other points where conductors are joined. Use a thermal imager to identify any hotspots, which can indicate loose connections or excessive resistance. Hotspots are often visible as bright spots on the thermal image. When the furnace is operating, monitor the temperature of the capacitors. Excessive temperatures can indicate that the capacitors are overloaded or that there is insufficient cooling. Use a non-contact infrared thermometer to measure the capacitor case temperatures. Compare the measured temperatures to the maximum operating temperature specified by the capacitor manufacturer. Also, evaluate the condition of the capacitor cooling system. Ensure that any fans or cooling systems are operating correctly and that there are no obstructions to airflow. Clean any dust or debris that may be blocking airflow. Check the voltage and current ratings of the capacitors to ensure they are appropriate for the furnace operating parameters. Using capacitors with incorrect ratings can lead to premature failure and excessive current draw. Confirm that the capacitor bank is properly grounded. A faulty grounding system can lead to voltage imbalances and increased current flow. Use a ground resistance meter to measure the resistance of the grounding system. The resistance should be as low as possible, ideally less than 1 ohm. Monitor the current in each phase of the capacitor bank. Uneven current distribution can indicate a problem with one or more capacitors. Use a clamp-on ammeter to measure the current in each phase. Compare the readings to ensure that they are balanced. Finally, review the furnace operating procedures and ensure that they are being followed correctly. Incorrect operating procedures can lead to excessive current draw and equipment damage. Ensure that the furnace is properly preheated before applying full power and that the melt is homogeneous before increasing the power level. Consider implementing a preventative maintenance program for the capacitor bank. This program should include regular inspections, testing, and cleaning. A well-maintained capacitor bank will operate more efficiently and reliably. Keep detailed records of all inspections, tests, and maintenance activities. These records can be helpful in identifying trends and predicting potential problems. If the problem persists after implementing these troubleshooting steps, consider contacting a qualified electrical engineer or furnace service technician for further assistance. They will have the expertise and specialized equipment needed to diagnose and repair more complex problems. Remember that working with high-voltage electrical equipment can be dangerous. Always follow proper safety procedures and wear appropriate personal protective equipment. De-energize and look at the equipment before performing any maintenance or repairs. Verify the absence of voltage before touching any electrical components. And be aware that capacitors can store charge even after the power is turned off. Discharge the capacitors using a suitable discharging tool before working on them. Always consult the equipment manuals and follow the manufacturer's recommendations. This information is provided for general guidance only and should not be considered a substitute for professional advice. The specifics of your furnace and capacitor bank may vary, so it is important to consult the manufacturer's documentation and qualified personnel for specific instructions. By systematically following these troubleshooting steps and taking appropriate safety precautions, you should be able to identify and resolve the issue causing the capacitor bank breaker to trip on your AJAX furnace. This will help to ensure the safe and reliable operation of your equipment. Capacitors are essential components in many electrical systems. They store electrical energy and release it as needed. Capacitors are used in a wide variety of applications, including power factor correction, motor starting, and filtering. There are several different types of capacitors, each with its own advantages and disadvantages. Some common types of capacitors include electrolytic capacitors, ceramic capacitors, and film capacitors. Electrolytic capacitors are typically used in high capacitance applications. They are polarized, meaning that they must be connected with the correct polarity. Ceramic capacitors are typically used in high-frequency applications. They are non-polarized, meaning that they can be connected with either polarity. Film capacitors are typically used in a wide variety of applications. They are non-polarized and have good performance characteristics. The capacitance of a capacitor is measured in farads. A farad is a large unit of capacitance, so capacitors are often rated in microfarads or picofarads. The voltage rating of a capacitor is the maximum voltage that can be applied to the capacitor without damaging it. It is important to choose a capacitor with a voltage rating that is high enough for the application. The temperature rating of a capacitor is the range of temperatures that the capacitor can operate at without being damaged. It is important to choose a capacitor with a temperature rating that is appropriate for the application. The equivalent series resistance, abbreviated ESR, of a capacitor is a measure of the capacitor's internal resistance. A low ESR is desirable for many applications. Capacitors can fail for a variety of reasons. Some common causes of capacitor failure include overvoltage, overcurrent, overtemperature, and aging. When a capacitor fails, it may short circuit, open circuit, or leak. A short-circuited capacitor will draw excessive current and may damage the circuit. An open-circuited capacitor will not function and may cause the circuit to malfunction. A leaking capacitor will slowly discharge and may cause the circuit to malfunction. It is important to replace failed capacitors as soon as possible. Replacing failed capacitors can prevent further damage to the circuit and ensure proper operation. When replacing a capacitor, it is important to choose a replacement capacitor that has the same capacitance, voltage rating, temperature rating, and ESR as the original capacitor. It is also important to choose a replacement capacitor that is of the same type as the original capacitor. If you are not sure which type of capacitor to use, consult the equipment manuals or a qualified electrician. When installing a capacitor, it is important to follow proper safety procedures. Always de-energize and lock up the circuit before working on it. Verify the absence of voltage before touching any electrical components. Be aware that capacitors can store a charge even after the power is turned off. Discharge the capacitors using a suitable discharging tool before working on them. Always consult the equipment manuals and follow the manufacturer's recommendations. When working with electrical equipment, it is important to be aware of the potential hazards. Electrical shock can cause serious injury or death. Always follow proper safety procedures and wear appropriate personal protective equipment. If you are not comfortable working with electrical equipment, consult a qualified electrician. Remember that safety is always the top priority. Now let's focus on impedance matching in more detail. The impedance of a circuit is the total opposition to the flow of alternating current. It is a combination of resistance, inductive reactance, and capacitive reactance. Impedance is measured in ohms. Impedance matching is the process of adjusting the impedance of a source to match the impedance of a load. When the impedance of the source is matched to the impedance of the load, maximum power is transferred from the source to the load. Impedance matching is important in many electrical systems, including radio frequency circuits, audio circuits, and power circuits. There are several different techniques for impedance matching. Some common techniques include using transformers, matching networks, and transmission lines. Transformers can be used to match the impedance of a source to the impedance of a load. The turns ratio of the transformer determines the impedance transformation ratio. Matching networks of circuits that are designed to match the impedance of a source to the impedance of a load. Matching networks can be made using resistors, capacitors, and inductors. Transmission lines are used to transmit electrical power or signals from one point to another. The impedance of a transmission line is determined by its physical characteristics, such as its length, width, and spacing. When the impedance of the transmission line is matched to the impedance of the source and the load, maximum power is transferred from the source to the load. In the context of the AJAX furnace, the goal is to match the impedance of the power supply to the impedance of the furnace coil and capacitor bank. This ensures that maximum power is transferred to the furnace for efficient heating. The capacitor bank is used to compensate for the inductive reactance of the furnace coil. The inductive reactance of the coil is proportional to the frequency of the alternating current and the inductance of the coil. The capacitive reactance of the capacitor bank is inversely proportional to the frequency of the alternating current and the capacitance of the capacitor bank. By carefully selecting the capacitance of the capacitor bank, the capacitive reactance can be made equal to the inductive reactance of the coil. When the inductive reactance and capacitive reactance are equal, the circuit is said to be resonant. At resonance, the impedance of the circuit is minimized and maximum power is transferred to the furnace. The resonant frequency of the circuit is determined by the inductance of the coil and the capacitance of the capacitor bank. The resonant frequency can be calculated using the following formula: frequency equals 1 divided by 2 pi times the square root of inductance times capacitance. It is important to maintain the correct resonant frequency to ensure efficient operation of the furnace. If the resonant frequency is not correct, the power factor of the circuit will be low, and the current draw will be high. This can lead to increased energy costs and potential damage to the equipment. Therefore, proper impedance matching is crucial for the efficient and reliable operation of the AJAX furnace.